Okay, LeChatelier. LeChatelier is just like a naughty teenager. Okay, he is the kind of guy that anytime you want to do something, he wants to do the opposite. If you want to go to the right, he will go to the left. If you want to walk forward, he will walk backwards. If you want a parachute out of a plane, he'll want to go up in a rocket. Yeah, it's just, I think it's fun to say that. But let's not waste too much video time on that. Here we go. I hope we're going to go. That's supposed to change the scene. Okay, good. Now, there are three stressors that represented by these three blue bars, and we're going to take these one at a time. We're going to do two of those today, and they'll be in your homework, those stressors, and then we'll do one tomorrow. The one that we're going to do tomorrow, that is heat and temperature. Okay, it works differently than the other two stressors. I mean, radically different. Okay? So, let's go down and let's see the rules for concentration. And why don't we get all three stresses down? There's only three stresses that you have to worry about with LeChatelier problems. Okay, there's the stress of concentration change. That's with an increase or decrease in the number of species in the water. And to make that just really, really short, it's adding something to the water or taking it out. Or if we're talking about, because this can be with gases or in aqueous solution, okay, that's what it says over here. With gases, concentration goes up, and if concentration goes up, LeChat wants it to go down. And how is he going to accomplish that? Okay, I'm trying to show you how to read this thing. A shift to the opposite side from the species in question. Okay? Or if we want to increase concentration because the stress was taking stuff out. If we're talking about aqueous solutions, the way we take stuff out is we put something into the water that will precipitate one or others of the species in the reaction, that are part of the reaction. So if we're taking stuff out by adding those external things, then the concentration of that species is going to get raised because of what LeChat wants to do. And he's going to do that by going to the same side as the species. That's how you increase. If you want to go to the opposite side of the, or if he goes to the opposite side, that will be decreasing the concentration. So this works for gases and aqueous solutions. So let's go ahead and do an example right away before we even talk about anything else. So here we go. If the computer will please respond. Oh my goodness, it's really slow with the recording going on. Here we go. Let's get rid of all these things so we can talk about them one at a time. Yeah, okay. So we're going to work on the equation you see here on the left. Okay? And notice what you're going to do. Well, I'll show you how to record this. You're going to record the first, second, third, and fourth lines. Okay? On your recording sheet. Does everybody have it? Yes. Example 1, example 2, 3, and 4. And example 1 is concentration. And example 2 will be concentration. And we'll be using this equation that you see on the board right now on the top left. Okay? Example 1. The stress that we're going to do is, well, I'll let you guys choose. What do you want to stress with? You can add or subtract anything in the balanced equation. Someone want to choose one? Now, I'll tell you what we're doing. I'll choose someone to choose porpoise. Okay, oops, that's 35. Where's my porpoise? Oh well. Okay, Yusuf, you get to be the chooser. So Yusuf, what do you want to do? Add or subtract FeSCN, iron, or FCN?
Iron.
What?
Iron.
Iron. Okay, iron. So your stress is going to be iron. Do you want to add it or take it away? Okay. So our first challenge to LeChat is to stress with iron ion concentration. We're going to increase it because we're going to add it to the water. That's what that means. So the concentration of iron, well, let's get the E in there. There we go. So concentration of iron is definitely going up. So what does LeChat want to do? He wants it to go down, of course. So now we have to think about our rules and see how that's going to happen. He wants that Fe, what was that, a plus or a 2 plus? 3 plus. 3 plus. Is that right for the video? So this guy is this chair. Here. There we go. Fe 3 plus. Okay. Now, what does LeChat actually do? Is he going to go to the side? He wants to take away iron. Now let's talk about how that happens. If he shifts to the right, see, LeChat can only do two things: shift right, shift left. Those are his only options. It's kind of a boring life. If you were LeChat, you would be bored stiff. All right. So if we take FCN and do a right shift, that means we're going to take Fe and SCN and separate them. And when we do that, this disappears as a species, molecule by molecule, and molecule by molecule, each one of these that I separate will be making an iron and an SCN. However, if LeChat shifts to the left, that's his only other option, he's going to be putting iron and SCN together and making iron. So what does he want? Or making iron thiocyanate. Okay, FeSCN. So, what do you think he wants to do? He wants to get rid of iron. Should he shift left or right? Come on, think. Okay? We had both. If we shift left, we take iron and SCN and make iron thiocyanate, which eliminates iron. At least some, not all, but some. If we shift to the right, FeSCN will be taken apart and we'll get more iron and more SCN. What does LeChat want to do? The side with the iron or the side without? Which way does he want to shift? Okay, you're saying to the left. So I'm going to write down what you just said. That means we're going to shift to side. This is really like we're going to shift to the side with FeSCN. And I'm going to tell you right now that that is a left shift because FeSCN is on the left. So that's when you write in your shift. I'm not used to the computer lagging that much. So there we are. How many have it right in their head so far? Yeah? Most of you? Some of you don't want to commit. Okay, I need another decision because I want to do a second shift with LeChat or a second trial on LeChat. give us a new stress? A stress will be adding or subtracting SCN, Fe3, Fe3 plus, or FeSCN. You want to take out SCN, okay? So, you want to do the stress, oops, I'm going to take it out. I was going to write an up arrow. That is definitely a down arrow. And we're going to do SCN. Minus 1. So, there we go. And so what does LeChat want to do? Ricardo? What? Yeah, okay. So that's an up arrow. And again, we're going to have Fe. Oh, no, not Fe. No Fe. No. Okay. Oh. Okay, let's go back. Oh, can I go back? Can I go back? Yes.
So that chart always went down.
Back here. Oh well. It doesn't matter. S, C, N, minus, and there we go. We're going to, LeChat wants to add the SCN. So, how is he going to add it? What do you think, Ricardo? Is he going to take this guy apart and make these two? Or is he going to put these two together and make this guy? Shift to the left, okay? If you shift to the left, you're going to take iron and SCN, and you're going to make this guy. You're removing iron from the solution. Okay, LeChat can only do one or two things. So the rule says we shift to side, and that would be because we want to increase with iron. If we want to make something, we have to shift towards the side where the stuff is. So what is that? Right or left? Huh? Yeah, he's on the right. So this is a right shift. Right. Okay? How are we doing? Is this making sense? All right. We have a different situation and different rules with the equation that's on the right side. Oh. I don't know why this is going so terribly slow. I closed everything else. Maybe it's still composing that other video. I don't know. But this is going really, really slow. So the volume of the vessel changes. Volume of the vessel changing. That's a horse of a different color. All right. Let's see if we can get this to go to. I'm going to pause.